Hi guys, in this video we are going to discuss about our digital to digital conversion or conversion, digital to digital. In this video we are going to discuss about unipolar, polar and bipolar. Okay, first of all, what do you mean by line coding? Line coding means converting the digital bits into digital signals. Okay, let's discuss how we are going to convert in unipolar. NRZ means non-return to zero, and polar NRZ, RZ, and biphase Manchester, differential Manchester. Okay, NRZ means non-return to zero, and RZ means return to zero. Okay, then our bipolar that contains AMI and pseudo-ternary. Okay, let's go. First of all, unipolar. Okay, this is a non-return to zero convention. Okay, first of all, when there is a 1, okay, from starting to end point of the time pulse. Okay, 1 is upper level, then 0 maintaining lower level from start to end, then again 1 maintaining higher level start to end, and again 1 maintaining higher level. Okay, then again 0 maintaining lower level. Okay, this is final, this is start. Okay, this is our non-return to zero in unipolar. You can take another example like, okay, these are some time frames. Okay, let 0 1 0 0 1 1 1 0. Okay. 0 means in lower level. Okay. Then 1 means higher level. Again 0 means lower level. Again 0 means lower level. Then 1 means higher level. Then again 1 means higher level. Then again 1 means a higher level. Then 0 means lower level. Okay, this is our non-return to zero model in unipolar scheme. Then here is polar scheme, non-return to zero model. Again, actually here are two model of non-return to zero. One is our non-return to zero NRZ-L level model, and NRZ-I model. I means invert. Okay, let's move to our L model. Okay, in level model, high level or maintain a high or upper voltage for 0, and lower voltage or negative voltage for our uh, 1. Okay, this is our amplitude. Okay, okay, then this is our A by 2. This is our A by 2, and this is our minus A by 2. Okay, A by 2. Okay, I have discussed that high level for 0 and low level for 1. Okay, then a positive A by 2 for 0, then 1 means a negative A by 2. Okay, then again 0 means positive A by 2, again 0 positive A by 2. Now connect. Then after 1 is negative A by 2, and again 1 a negative 1 by 2, and again 1 negative 1 by 2. then connect this. Okay, then 0 means positive a by 2. Okay, then let's move towards our NRZ-I invert. Okay, non-return to 0 invert. Okay, here you have to understand one thing, that when we get a 1 in our next bit, we have to just invert. Okay, this is also a by 2 and this is minus a by 2. Okay, for 0 it's a positive a by 2, and in next bit we are getting 1. So here is the invert. Okay, in negative, and then our 0, then 0 will continue. Okay, 0 will continue, and again 0 it is continue. In next it is 1, so a invert. Okay, then again is again a 1, it will invert. Okay, then again a 1, it will again invert. Again a 0, it will continue. Okay, two rules. If there is a 1, then this will invert. If 0, it will continue. Okay, I'm writing it on the side. Continue on 1 invert. Okay, again I can check that there is a first is 0, then a 1 means inverting, then a 0 means continuing, then continuing, then continuing. Okay, if a 1 then inverting, then again the next bit is 1 inverting, then the next bit is 1, then again inverting, then 0 continue. Okay, then another model, return to 0 model. Okay, return to 0 means simply in the middle of the signal, or in the middle of the time pulse, it will return to the 0. Okay, similar. You can draw like this. Okay, and this is our amplitude, and this may be our a by 2, and this may be our a by 2 minus a by 2. Okay, then, and this is our 0. Here is 3 value maintained. One is positive, and one is negative, and one is 0. Okay, every signal will return to 0 in the middle of the time pulse. Okay, or every bit return to the 0. Okay, here is a 0, then started from negative and return to 0. Okay, then next bit is a 1, started from positive and return to 0. Then here is again 0, started from negative, return to 0. Again a 0, started from negative, return to 0. Then a 1, started from positive and return to 0. And if there is another one, then it will started from positive and return to 0. Okay, like that our return to 0 model works. Then there is another Manchester and differential Manchester, and this is mainly our IEEE 802 model, 802.3 model. Okay, 0 means high to low, and 1 means low to high. Okay, in Manchester 0. Okay, You can also tell that this is our a by 2 and this is our negative a by 2, and then 1 move towards our 1, then our 0, okay, then again 0, high to low, and then 1, then low to high, then again 1, then low to high, and if there is again a 1, then it's low to high, okay, like that. Then how, okay, then move towards our differential Manchester. Here is actually 2 value for 0 and 2 values for 1, okay. Let's check. For 1 there is actually this type of signals, and from 0 this type of signals, okay. Let's check. Here is a 0 and we are drawing this, then it's a 1, and it's again a 0. We will continue from that point, we will continue from that point. Here the signal ended, or the bit ended of 0. We are just continuing from that point 1, okay. And then this is the 0, okay. We are using this, sorry, we are using this model. Then again a 0, okay, again using this, then a 1, continuing from here using this, okay. Then again a 1 using this, okay. Okay, be careful, okay. This is a 0, this is a 0, okay. So this moves from here, and this is a 1, simple. Then this is 0 again, started from here, and again this is a 0, started from here, here. Then this is from here to here, then this is definitely 1, okay. Then this is definitely 1, these are the points. Then we have our bipolar scheme. One is AMI and another one is pseudoternary. Okay. Let's discuss about AMI. In AMI, the 0 will be maintained, okay. 0 will be maintained as 0 value, then 1 will be inverted. If this time the 1 is in upper voltage or positive voltage, then next time this will be the negative voltage, okay. Let's discuss. 0 in 0 time axis, then 0 amplitude, sorry, 0 in 0 amplitude, then the 1 positive, then 0, then 0, then 1, then 1. This is positive, okay. So this is a negative, okay. Then 0, then again, and 10, okay. Then a pseudoternary is a simple opposite, okay. If there is a 0, then it will invert, and 1 is maintained in 0th place, okay. In amplitude value 0 amplitude, the 1 is maintained, okay. First of all, let me do some leveling. This is our a by 2 and this is our 0, okay. This is our 0 and this is our a by 2. This is our minus a by 2. Okay. Okay. Then this is also our minus a by 2. Minus a by 2. Okay. So in pseudoternary, just opposite of AMI, for 0 it is inverting. This is our current 0, it's positive. Okay, then this is 1. Okay, then this is 0, so negative because inverting. Okay, then after again 0, positive, inverting. Okay, it's a 1. Okay, in 0th level, then again a 0, negative, negative. Okay. Okay, these are the encoding conversion widths. Okay, or conversion types and schemes. Okay, thank you.